are live. All right, so today, what I want to do is talk about polynomial behavior. What the heck does that mean? So we're going to look for where it is at the top, maximums, minimums, and when it turns, okay? That's what we want to do. Okay, and we've already talked a little bit about this. So, easiest way to talk about local max, local min is just to put a graph down, right? So, put a graph, and I'm just going to draw a graph in. Okay, it doesn't have to be perfect because we just need to find the spot. So the local max really is the highest point. The highest point is like the top. The max is like the top of the hill. And in this case, that'd be my local max right there. The reason we call it local, which I've already explained to you guys, but I'm going to do it for everybody else who wasn't here, is the fact that this is my local max, but there are points that are higher up, but it's not the top of a hill, okay? And that could tell us a lot in business. We could say, okay, well, right now, here's where our maximum is. If we continue to increase our prices, we'll start to lose money. Does that make sense? Right here's our perfect price. If we continue to increase our prices, we'll start to lose money because it will be too expensive, right? Or maybe our price is too low, right? And then the local min, of course, is the bottom of the hill. I know, real mathematical words, but it makes sense, right? So there's my local min. And the same thing. So in business, we could say at this point in time, our expenses, we go to our expenses. Our expenses are the least. That's good. And then all of a sudden, our expenses get higher, right? So maybe what we need to do is fire Mr. Davies or whatever, and then we can start to make some money, okay? Maybe I'm too expensive. And then the inflection point is, it's called a turning point. And it's where you go from concave down to concave up. We talked about how if you were on a roller coaster, you'd be screaming down here, and then right about here, you'd start to slow down, right, to go up the hill. So an inflection point is where you go from concave up or down to concave down or up. And for me, I think I'm just going to try and eyeball this. It seems like it might be right about. There, maybe. That looks like my inflection point. And most of the time, it's right in between the two. That makes sense. Most of the time, it's right in between these two, because you go from local min to local max. Hold on. Did I turn that off? I had that turned off. So let's go ahead. You guys have your decimals. Let's graph the next one, okay? Get your phone out. I know I can't believe I'm saying get your phone out, right? But I am. Oh, there it is. Pandora. So let's graph this one, and let's find everything. X and Y intercepts, local max, local mins. And decimals can do so much of this, okay? So okay, so let's go to Desmos, and we're going to go y equals, and I'm going to do a 1/6. I'm going to use parentheses for the 1/6, right, over, and then I'll do my parentheses, and I'll do an x plus 3. Oops. X plus 3, parentheses, we'll do an x minus 2, and I'll square it, okay? There we go. Okay, so there's my graph. So there's a few things that are easy to get, because the calculus, this Desmos makes it easy, okay? Wait for you guys. Everybody have it? Emma, you still putting it in?
Yeah.
Okay, I'll wait for you, right? So what I love about Desmos is I can just tap. There's my max. So my max is at, I'm going to write that down, my local max. Local max is at negative 1.3, probably repeating, and about a 3 point, we'll round to the nearest tenth, 3.1, okay? And if I want my local min, we'll just tap on it, right? So there's my local min at 20, so my local min is at 20. And now the inflection point. I'm not sure where the inflection point is, but I'll try and figure that out, okay? So I know I'm going to also have this point right here. And that point's got to be an X-intercept, right? That point's an X-intercept. So I also have an X-intercept at negative 30. And of course, I also have this 20. Those are X-intercepts. They both are. If I look at my calculator, okay, and that's an X-intercept, that's an X-intercept, right? And I have a Y-intercept right about there at 0, 2. Okay, so just tap. So I've got a Y-intercept at about 0, 2. Okay, so I can at least put some of those pieces of information on my graph. Okay, so 2, 0, that's my min. My max is at negative 1.3, and about 3.1 is about there. X-intercept is at 0, 3. Got that. So I've got enough to at least start to graph it, okay? And I've got my Y-intercept there. So it looks something like that, right? Okay. Now the inflection point, okay? The inflection point's got to be in between, in the middle of these, okay? So now I'll do a little bit of math, but the inflection point has to be in between these two, right? Has to be in between here and here. So somewhere around in there, okay? So how am I going to figure that? Well, I'm going to take their x's, and I'm going to go from a negative 1.3, and I'm going to go all the way to 2, right? So I'm going to go from here to here is my spread. So my inflection point's in the middle, right? So that's a total of about 3.3. That's a distance. So from here to here is about a distance of about 3.3. And I know my inflection point's in the middle. So if I just take half of that, so if I take half of my 3.3, okay, you ready? If I go 3.3333 and divide that by 2, I get about 1.6, right? So somewhere in here is got to be my inflection point. Okay, so if I take, hopefully this is not confusing for you. So from right here, if I move over 1.6, I'll have my inflection point, okay? All right, so I'm going to take my negative 1.3, and I'm going to add in that 1.6, and I should get, what, about a 0.3, right, about a 0.3. So then what's the y value? Well, let's plug the y value in. So then my inflection point is at 0.3 something. Well, how do I get something? How do I get the y value of any problem? I just plug it in, right? So I'm going to take and plug it into here. So I'm going to take and go, all right, I'm going to go y is equal to my 1/6 times my 0.3, we'll just round up, plus 3, 0.3 minus 2 squared. I'm just going to let my calculator do that work, okay? All right, now I'll review what I've done here in a second, okay? So I've got 1/6, 1 divided by 6, whoops, press these the wrong way, times a 0.3 plus 3 times a 0.3 minus 2 squared, and I get an answer of about about 1.6, okay, about one, all around 1.6. Okay, so that's where my inflection point is probably at, is about 0.3 and about a 1.6, right about there, okay? All right, highlight that. So, before I move on, the inflection point's a little tricky, okay? So again, here's my max, there's my min, right? My inflection point's right in the middle. Had to get that, I figured out how much was from here to here, what was the spacing. From here to here, we found out was a spacing, x value spacing of about 1.6, right? And then what I did is about 3.3, and then I took half of that to go halfway, and I got my inflection point, okay? All right, turn the page. Let's do the next one, okay? All right. So, again, to do this, I am just going to use Desmos, right? Let's just make this easy on myself. So let's go ahead and make it a y equals a 6x cubed, right? Plus a 5x squared, subtract a 17x, subtract 6. Okay, there it is. Let's see if I can make it look, oh, we're almost there. Make it wider. Small, come on, get it for me. That's probably the best I'm going to get, okay? So let's tap. Let's get, first, I'm going to get my max and my mins first, if I just tap on it. So hopefully you can see that at home. So my max, let's just tap. Okay, my max is at about and we're going to round the nearest tenth, about a negative 1.3, comma 11.4, okay? Okay, that's not bad, that's easy, right? And then my min, I'll tap. And my min, my local minimum is at about a 0.7. And it looks like about a negative 13.4. Okay. X-intercepts, let me see here. I can get X-intercepts by just tapping on it. So let's get my, first of all, X-intercepts. So X-intercepts, I'm going to have one at tap, tap, negative 2, 0. And, where's the other one? At about a negative 0.3, 0, and about a 1.50, okay? See all those? I love Desmos. Okay, so let's graph those. Oh, and I got a y-intercept, my bad. The y-intercept is 0, negative 6, right? And a y-intercept of 0, negative 6. My y-intercept is at 0, negative 6. Okay, so I took everything from my phone, from Desmos, and now I'm going to graph it all, okay? So I'm probably going to need to change my scales because I've got to go all the way down to 13, 2, 4, 6, 8, 10, 12. Yeah, so let me go by 2s on my y scales, okay? Negative 2, 4, 6, 8, 10, 12. So negative 13 is right about here somewhere, okay? And so it doesn't have to be perfect because I have it all here, but negative 1.3 and 11. So negative 1.3. I'll go by 1s. So I'm going to go by 1s on my x scales. I'm going to go by 1s and go by 2s on my y's, okay? All right, so let's see if I can graph this. So first, negative 1.3 and 11.4. Negative 1.3 is about there, and 2, 4, 6, 8, 10, 11 is about there. Just close enough, right? There's my max. Min is about 0.7, 11.4, 2, 4, 6, 8, 10, 11.4, maybe right about, I'm going the wrong way. 13. Okay, no wonder. 2, 4, 6, 8, 10, 12, 13.4, maybe right about there, okay? Okay, so I got my max. I got my min. So now let's get my x-intercepts. Okay, negative 2, 0. I've got a negative 0.30, and I got a 1.50. Okay, so now here's what my graph looks like. Of course, we got this off. Oh, lousy graph. Sorry, you guys. Oh, terrible artist. Oh, and we got 2, 4, 6. We got that one there too. Okay, there's my graph. Lousy looking graph, right? All right, so now let's see if we can get that inflection point, okay? So the inflection point's got to be in the middle, right? So my inflection point is in between my max and min. So let's find the inflection point. little bit harder to do, but we can do it. Inflection point. So I'm going to go from a negative 1.3 to a 0.7, okay? That's the spread from max to min as far as x values, okay? If my inflection point's in the middle, right, then what I've gone is a total of 2, right? I've got negative 1.3, I go 1.3 to 0 is 1.3 plus 7, so I've got a spread. So my spread between the two is 2 units. Okay, does this make sense? I mean, this is the part that I want to make sure you get, okay? So from here to here is 2 units. You guys agree? I'm going to go 1.3 and then another 0.7. So then I take half of that, which is going to be 1 unit. So halfway is going to be my inflection point. So let's just take this 1.3, negative 1.3, and move forward 1 unit. That would put me at a negative 0.3, right? Something. Okay, now to get the something, we just plug that back in to my original equation, which was my y equals my 6x cubed. We're going to go 6 times my negative 0.3 cubed plus my 5 times my negative 0.3 squared minus 17 times my negative 0.3 and then minus 6. And I'm going to use my calculator to plug it in. Sorry, that's also squishy. Probably should have started over here. But anyway, let's see what the calculator says we get. Okay, clear. I'm going to go clear. I'm going to go 6 times my negative 0.3 to the third power plus 5 times my negative 0.3 squared minus 17 times my negative 0.3, subtract 6, and I get an answer about negative 0.6. Okay, negative 0.6. I'm going to write that down. Let's see if that concurs. Okay, so I'm going to have a negative 0.3. So it's right about there. My inflection point is right about there, which puts it halfway between my max and my min. This is a little bit harder to do, but just think before I finish. Think, what you're trying to do is find the middle between these 2 points. So to get the middle between these 2 points, what I did is I found out how much distance is between these 2 points. Not the y's. Actually, the y's would work also, but the y's would work, but the x is what I want to tackle. I found the x value in the middle, and then I plugged it in to get its corresponding y value, okay? All right, that's what I have for today.